now. Okay, who would like to talk me through it? Who did this a different method that they would like to share? Yeah, Kamaz, I see your hand is raised.
Okay, so basically, we said previously that you need K and you multiply the amplitude by K to get the big amplitude.
Correct.
Now, this time we have K squared, which is 10.
Correct.
So
yes.
if you just say the square root of 10 times 2, you'll get the amplitude.
Correct. So in other words, K is equal to square root of 10. That's absolutely correct, which means that A2 is equal to square root 10 times by A1, which is equal to 6.32 without having to do the maths. And that's absolutely correct. Now, if you look at that, and if you look at using the so-called formula, you'll realize that you've actually done the same things in a different order of events, because you did the squaring, but in this case, you did the squaring at the end. Here you did the squaring in the beginning. And in the beginning, you worked out the ratios of A1 to A2, sorry, I1 to I2. You worked out that ratio. In other words, you solved for this little component over here. Yeah, and then you square rooted it afterwards. So you've essentially done exactly the same thing. You just did it in a different order. But that's absolutely correct. Now, which way you choose to solve it in a test or an exam is entirely up to you, because you can either use the formula as is, meaning just learn this formula and then summarize it and add it to your list of things to remember, or you can solve it step by step from first principles using the concept of K and K squared. Cool, so I've got 2 problem questions at the bottom, then we'll end the lesson. So I literally just Googled these off the internet 5 minutes ago. Waves from a source have an amplitude of, yellow, talk to me.
I want to ask, but then what is intensity? Like,
intensity is on page 290, whatever it is in your textbook at the beginning of the thing. It's basically the power over the cross-sectional area. In other words, how much energy. So if you take power divided it by area, you can think of power as joules per second over area meters squared. In other words, if I take a certain patch of ground, and if I think of the sun shining, so like light waves from the sun, I'm saying if I take a small little area here, how much energy, joules, is reaching that area per second for every meter squared. So if you think about a meter squared patch of ground on the Earth, so that's a 1 meter squared patch, the question is, how many joules are entering that every 1 second? So how much energy is reaching that 1 meter squared patch in every second?
And in relation to waves, it's just the energy in the one wave compared to the energy in
correct,
the other wave.
100%. So in other words, the amplitude of the wave in this case was undefined. The amplitude we were measuring in so-called centimeters and meters and whatever, but we didn't specify whether it was a sound wave, a light wave, or water wave. We were just saying we could measure the amplitude of that particular wave. So it wasn't necessarily even the spring that we looked at yesterday. It could have been any wave. So I'll give you an example of if you have a water wave like this, and if you think of the amplitude of the water waves, you could measure the amplitude, and then you could work out the intensity of the wave based on its amplitude. And what we're saying is that the intensity decreases with square of the decrease of the amplitude. So half the wave, a wave that is half as small as another wave, doesn't have half the intensity, it has a quarter of the intensity.
Gotcha.
Cool. Okay, so we've got these 2 questions here. We've got approximately 15 minutes, then it's chemistry, but we'll take a quick break. We'll come to chemistry at maybe past or something. That's not a problem. So it says waves from a source have an amplitude of 5 centimeters and an intensity of 400 watts per meter squared. So here they're giving you the intensity as an actual value. Cool. So they say the amplitude of the waves is increased to 10 centimeters. What is their intensity now? So I want you to do A quickly, just on your own. And you can do it in whatever way you want. You can draw a diagram, you can use the formula, you can use K, you can use K squared, but I want you to quickly do that on your own. Cool, so I'm gonna pause the recording. Ooh, guys, I'm just talking in the background quickly so that I can record it on the video. I forgot to press record. So for those of you at home listening, what we did was we plugged in the values into the equation. So we took the original length, which is 5. We plugged it in over there as the original amplitude. We plugged in the second amplitude, which was the 10. We put that over there. And we plugged in the original intensity, which was the 400, and we plug that in over there. And then the only thing we don't know is the second intensity, so we can solve for X, and that is how we would do that. Also, for those of you that missed it at home, that's for you. Not Angelica, because Angelica's already had a turn. Sorry, I love you, but no, not today. Ooh, Kamaz, Vimbai, Nico.
I did both methods.
Sure, okay. So which one would you like to tell me first?
Maybe the K one.
Okay, so you did the K one. Okay, so talk me through it and I'll try to keep up with you.
Okay, so we know that the intensity of the big wave is 16,000 and the new smaller wave is 100. So I drew it like it continues. So I drew it as like one continuous wave.
So you said 1600 goes to 100. Yeah. Is that what you said? Yeah. Okay. You know what you did? You linked A to B. I don't think you're supposed to do that. I think B was an entirely new question on its own, starting with the original 400.
But I got the same answer.
It's possible. Okay, so let's have a look. So if you said 1600 decreases to 100, then what did you say after that?
So I said 1600 divided by 100 is 16, and that is K squared.
Correct, which is the K squared. So
and the amplitude of the 1600 is 10 centimeters.
Correct, it's 10 centimeters.
So since you're going to a smaller one, if you divide by the square root of K, you should get the amplitude of the other one.
I believe that is correct. So in other words, you're going to divide by, 16. No, you're going to divide by 4. Yeah, square root of 16, yeah. Correct. Yes, divide by square root of 16, which gives you some answer. I think it's basically the 2.5. It should be, yes, it's dividing by 4. Of course it is. It's dividing by 4, which is 2.5. And it's correct. You got the same answer because instead of scaling down the 400 to the 100, you scaled down the 1600 to the 100. So you could have also started with the amplitude being 5 and the intensity being 400, and you're absolutely correct. You would get the same answer. So what you did is you started up with the scaled up version. But yes, you would get the same answer if you used the other one. Okay, so who wants to do it starting with the original values and using the formula?
I nominate Nico.
Nico? Vimbai has been very quiet.
So I don't get that answer. I think because I used the original 1600 as well.
No, and the thing is, it actually doesn't matter which one you use. So what I'll do is I'll write down the intensity for you. So I'll say I2 over I1. So if you start with the original 400, I1 squared over I2 squared. So let's start with the original 400 and it scales down to 100. Then we have to start with the original amplitude, and the original amplitude was 5. So we're saying start with the original 5 squared. and solve for amplitude 2 squared. So if you solve for amplitude 2 squared, you'll get 2.5 centimeters. Cool. So I'll leave you to do that calculation on your own in terms of solving for A2 on its own. Cool. But if you started with the 1600, you could have done exactly the same thing. You could have said I2 over I1 is equal to A1 squared over A2 squared. And now if you started with the 1600 and you scaled it down to 100, the only difference is now you have to use the new amplitude, which is 10. So you have to use the new amplitude, which is 10. And in other words, you can put over here 10 squared is equal to A2 squared. And if you solve for A2 squared, you're going to get 2.5 centimeters. The only difference is when you start with the 1600. So when you start with the 1600, which is this over here, you have to start with the amplitude as being 10. But if you started with the 400, then you start with an amplitude of 5. But you get the same answer because you're scaling it down to the same wave. For B, you're scaling it down to the same wave. Cool.
Cool.
Okay, so I'm going to stop there. I'll leave you guys to read the book and come up with your own summaries and conclusions, and then we'll carry on tomorrow.